Hello and Assalamualaikum warahmatullahi wabarakatuh. Today we want to explain about Single Instruction Multiple Data Stream or SIMD. This is our group member. INTAN SORFINA binti Muhamad FADHIL, Muhammad Aizat bin Nasir, NURUL BATRISYIA binti Muhamad NIZAR, KAMIL PUTERA bin ARIFF FAHILLAH, and BALQIS KHALISAH binti ZAINUDDIN. In this video, we will explain about introduction of SIMD, concept and features, advantages of SIMD, disadvantages, implementation and application of SIMD, and the summary.
Hello, I'm SORFINA binti FADHIL. Here I am to explain about the introduction of SIMD. SIMD stands for Single Instruction Multiple Data Stream. SIMD can be described as a class of parallel computers with multiple processing elements that perform the same operation on multiple data points simultaneously. In 1970, the first use of SIMD instructions with CDC*100 and TI-ASC machines that managed to accomplish the same functionality on a batch of data. In 1996, Intel made SIMD widely available by adding MMX extensions to the x86 architecture. Then, Intel reacts with SSE. SSE stands for Streaming SIMD Extensions. And recently, SSE and its extensions are more applied now. Nowadays, the majority of the modern processor designs contain SIMD to increase the performance of each computer.
You might be wondering, what is the concept and features of SIMD? Well, my name is NURUL and I am going to explain to you the concept and features of SIMD. The main features of SIMD is, each processor has its own memory, and it also has large number of small or simple processors. The concept or mechanism of the SIMD is, one instruction does the work of multiple operations. It performs same instruction on multiple data elements. It is also called short vector instructions. Other than that, it is also called subword parallel instructions that perform same operation on each subword in a register. SIMD units refers to hardware components that perform the same operation on multiple data operands concurrently. SIMD units include basic arithmetic operations such as multiplication, addition, subtraction, and other operations such as absolute value or square root. For example, the sub-corresponding elements in A and B are stored, which result in array C equals to A plus B in a loop.
Hello, my name is Muhammad Aizat. What is the advantage of SIMD? The first advantage is it can process multiple data elements at the same time with a single instruction. So, it will improve device performance. The second one is it can process multiple data only under one instruction. So, this can take much less time than retrieving each pixel individually. The third advantage is it can conduct mathematical operation that square measure applied to giant set of information point in an exceedingly a lot of faster. So, it will reduce time to complete the task.
Hi, I'm KAMIL, and I'm going to talk about the disadvantages of SIMD. Not all algorithms can be applied to SIMD. For example, passing applications do not gain the benefits of SIMD because it cannot be vectorized easily. SIMD technology consumes quite a bit of power and also uses small space on the microprocessor chip because of large register file. Implementing SIMD supported instructions in the computer program significantly involves more human interaction than traditional programming, such as C or C++. SIMD instructions are very architecture specific and require more recording to extend the application that's using it across platform. SIMD may also have restrictions on data alignment. Programmers that are not familiar with it may not expect this different type of architecture. It is also particularly tricky to gather data into SIMD registers and scattering it to the correct destination, which sometimes require permute operations, thus leading to inefficiency. Thank you.
Assalamualaikum. My name is KHALISAH binti ZAINUDDIN. Now I will present the implementation and application for SIMD. First example is vector processing architecture. The vector processor is the processor that instructs and operates on vectors, not on the single data value. Depending on how parameters retrieve, vector processors are often classified into two types: memory-memory structure and register-register structure. These architecture memory parameters are streamed to the functional memory units in memory structure coefficients, so the results are rewritten to memory while the vector process continues. In register-register structure, operation and the results are rewritten indirectly from the memory through the use of a large number of vector registers. Advantage of vector processor is it is portable to any architecture FPGA, scalable to higher performance designs, and versatile. Second example is array processing architecture. This is called a two-dimensional array or matrix in the array processing architecture. The basic form of diagram is the matrix introduced by the two-dimensional processor. In the array processor, the working mechanism is that a CPU in the processor issues a single instruction and then applies it simultaneously to a number of data. This structure is based on the fact that all datasets operate on the same instructions. But if these datasets are dependent on each other, it could be not possible to apply parallel processing. So relative to the overall instructions, the array processors contribute efficiently and increase the processing speed. To alleviate the vector processor bottleneck problem is the advantage of the array processor.
In conclusion, SIMD solves many difficulties in processing multiple information that works in parallel operation simultaneously. We also can conclude that the technologies used SIMD also perform very fast compared to the non-SIMD technologies. Last but not least, SIMD brings a lot of benefits in computer system in terms of execution time performance, energy consumption, scalability of data size, and provides concurrently.
That concludes our presentation. Here are the references we use. Thank you for watching. Goodbye.